This video describes the research study interaction with a virtual content using augmented reality, a user study in assembly procedures which was developed at the University of Aveiro, Portugal. Assembly procedures are a common task in several domains of application. Augmented reality has been considered as having great potential in assisting users while performing such tasks. However, poor interaction design and lack of studies often results in complex and hard-to-use systems. To compare different interaction methods using augmented reality, we implemented a prototype to guide users during a virtual assembly procedure. We selected two interaction methods based on handheld augmented reality, as mobile devices present very interesting characteristics. The other method is based on a video see-through head-mounted display and 3D controllers, a configuration offering a more immersive experience. Method 1 explores touchscreen gestures using a mobile device. Users can move predefined objects in 2D by dragging the finger in the screen. Depth and rotation of the objects can be changed using buttons that rotate the object 90 degrees and the depth of the object by 50 centimeters. It is also possible to manipulate several objects at the same time. Method 2 explores mobile device movement. The object pose is controlled by the movement of the mobile device. This bound is a fixed geometric relation, implying that all 6 degrees of freedom of the object are anchored to the device movement. Method 3 explores the controllers from a see-through hand-mounted display to manipulate virtual objects. The controllers provide a natural 6 degrees of freedom interaction mechanism which allows to select objects by press and hold the controller's trigger and move them in the surrounding environment attached to the controller. To compare the usability and acceptance of the three augmented reality assembly guidance methods, we conducted a user study with 27 participants following a within-group experimental design. To minimize learning effects during the experiment, the participants were split in 3 groups and each group performed the 3 conditions in different orders. The independent variables was the interaction method provided to the users with 3 levels corresponding to the experimental conditions. C1 – touchscreen gestures using a mobile device, C2 – mobile device movement, and C3 – controllers and C2 head-mounted display. The task focused on assembling a virtual reality car using Lego brick with all conditions. In total, 9 instructions that were 3-dimensional in nature. Participants were required to place the brick pieces in the predefined pose shown visually by a transparent Lego brick. Performance and participants' opinion were the dependent variables. Task performance is defined based on the time of completion, logged by the device measured in seconds. Participants' opinion was obtained through a post-task questionnaire to assess ease of use of each condition as well as preferences. In addition, participants completed the assembly tasks while observed by an experimenter who assisted them if they asked for help. The experimenter used the standard form to make annotations. Results showed that participants were faster when they used condition C3 as depicted by the box plot. In addition, participants' gender and previous experience with virtual and augmented reality, as well as assembly, did not cause significant differences. In addition, a training period may be necessary to master the interaction method of condition see-through the device movement as depicted by the chart. Regarding the post-task questionnaire, the majority of participants found the assembly instructions easy to understand. 26 participants indicated condition C3 as their preferred condition, although they reported symptoms of nausea, sickness, or disorientation, which may be caused by latency. Conditions C1 and C2 may prove a good compromise between an efficient and accurate interaction mechanism, portability, and budget. In addition, participants suggested the use of haptic gloves, hand recognition, and a mix between the characteristics of conditions C1 and C2. It is also important to address that the Lego car assembly is a fairly simple task. The use of a more complex and realistic task might show more clearly the benefits and limitations of the different methods. Likewise, the see-through head-mounted display condition is significantly different from the handheld, which may have an impact on the results, as the direct manipulation is a more effective interaction, but also causes some discomfort to the users. As such, further studies with all the interactions implemented in the head-mounted display setup might be a possibility to minimize the differences and realize a better comparison. To conclude, participants prefer and run faster using the controllers and the see-through head-mounted display of Condition C3, although this device causes some symptoms of nausea, sickness, and disorientation, which means that for long periods of usage, Condition C3 can cause an impact in the users. Moreover, the mobile device movement seems to require more training to be correctly used. As future work, we are already working on the integration of the methods into a collaborative augmented reality platform for co-located cooperation. In addition, we intend to conduct a larger-scale collaborative study to obtain more insight regarding which method stands out in a collaborative context and why, as well as assess user awareness, interest, and social interaction. Thank you for your attention. If you have any questions, don't hesitate to contact our research group.